So today I wanted to focus on being able to capture a full mesh from the depth API. And so the depth API, it gives you kind of an image that is the depth. And if you map those depth points onto a planar mesh, that will give you a loose representation of the actual area or materials that are in front of you. The thing that is a little bit misleading though is that because you're projecting it onto a flat surface, you won't be able to get any dips around that surface. So it'll be kind of more like a 3D painting rather than something that is a full 3D mesh. So it is not a replacement for photogrammetry because it is limited in the fact that it can only project onto a plane, and a lot of images cannot be projected from a plane. If you have something like a table, it has things that are behind it, and with this planar method, we are just going to end up with a projection from a plane. So one of the limitations that webxr has is that because it tries to create a separation between the camera and the actual scene, it's a little bit difficult to get camera information within the scene. So we'll look at that a little bit later, but for now, it's just important to realize the reason why this is all colored green is because it's difficult to get that information from the camera into our textures. We could have used the depth image to get some sort of texture, but that's just why it's green for now. And what we're going to be using this for in the near term is to be doing some dynamics, and I have some other ideas coming up too. So we won't actually be using an image texture in the near future, but once these things get a little bit more developed, you should eventually be able to get media requests from your phone to the 3D scene. But I think that requires some security considerations, and so they're a little bit backlogged on that. Okay, so now onto the code. So to start off with, we are just going to start with the depth information. So every frame this gets called, and we will build the rest of the code around this. So we're just going to focus on the important part of what we're learning today, and then afterwards we'll wrap that all up. So to start off with, we get the depth information from the frame. And then we're also going to check for a flag. If that flag is hit, we will do this next part. If we consistently gather meshes, it's just going to make our phone start on fire. So we're just going to do it once, then we'll set the capture false, and then we are going to set some sort of scaling value. And so this has to do with the camera field of view. So this is just some trigonometry that we'll show off. Then we get the ratio and we will build out the plane. So this plane will be the size of our camera image. And then we are going to get the vertices from that plane that we've built, and we will get the data from the depth data and put it into an integer array, and then we will get a conversion rate from our depth information as well. So now we're going to be looping over and setting up all of the variables, all the little vertices, so that they match up with our depth information. First, we'll just convert it into a raw z distance, and so this will be the distance in meters, and we want our vertices to be matched to those meters. But because of geometry, we have to do a little bit of extra manipulation. So basically we'll use similar triangles. This is a little bit of a questionable way of doing it, but it kind of looks right. So we're just going to stick with this for now. And then we set the z distance, and that's the one that is very straightforward. Okay, so now we will get our mesh material. We'll add that to our mesh. And then we're just going to copy our mesh to the position and to the rotation that our camera is in so that it lines up with where the image was taken. And then we just have to rotate it because it ends up being upside down, and there's probably another way you could have done that, but yeah, it ends up being upside down. So, or it's lopsided. But yeah. And then what we do is we just wrap this all up in every time an on frame gets called. And yeah, we have the poses, the viewports and all that. Then we have to also move our light around, and so you don't need to do this, but without a moving light, it's really hard to kind of calibrate the distances because we're using a very flat color, which we are using because it's a little bit hard to texture it. So if you paid a little bit more attention to materials, you might not need this part. And then we just add in our kind of rendering every function, and the rest of this is going to be very boilerplate stuff that we've done a few times now, where we just have all of our variables, we have our initialization function, we add in our lights and all of the other stuff, and just some updating functions and some rendering functions, and then we're just going to attach some of our buzz, and that's basically it. Oh yeah, also we do need to make sure that we are initializing the depth sensing API with the CPU optimized and the luminous alpha section, and we also need to add our on X frame start to when our XR session initially gets started. So our HTML here is very similar to other projects. The one distinguishing factor is that we have two buttons, and those just have the ID of capture mesh and then also delete mesh, and that's just it. Yeah. Okay, thanks. Have a good day. Thanks.